Hello friends, welcome back to this lecture on memory. Continuing from the last class where we are discussing about long-term memory, in the upcoming lectures we will discuss on the types of long-term memory which are available for humans, and we will see what are the properties of this memory, how do they function, and several other qualities of these memories. So, let us begin this lecture on semantic memory. Now, if you remember from the last class, I discussed about the way long-term memory is organized, and so what we saw in the last class was that long-term memory had two separate distinctions. So, two separate parts of it, and I also explained a little bit about the distinctions of these two parts. So, these parts are the declarative and the procedural type of memories. Now, declarative, if you remember from the last class, declarative type memories are those memories which have conscious awareness. People are consciously aware. So, when performing this memory, people know what they are doing, and so they basically take part in these memories, consciously remember, are well aware of what is happening. And so, memories of events, memories of facts, memories of other kind of memories which you know that you are acting on or you are thinking of are declarative in nature. And so, the declarative memories are then divided into two parts. Also, declarative procedural memory can also be subdivided in terms of explicit. So, some books would talk of declarative memories as an explicit memory and the procedural memory as an implicit memory. So, and this explicit implicit is basically dependent on the amount of consciousness that you are putting onto it. So, whether you are aware. So, if you are aware of a particular memory type, it is declarative. If you are unaware of a particular memory when it is functioning, this is the implicit type. And so, there is a debate on these two types of memories of declarative and procedural or two memories area. Now, looking at the subdivisions, the declarative memory is divided into two subdivisions. We have the semantic memory and we have the episodic memory. And so, the upcoming few lectures will be basically focusing on the semantic and the episodic. Now, procedural type memory, where people are not aware of that they are accessing the memory, is basically implicit, and basically implicit in nature is something which we will not discuss here in this particular introduction to cognitive psychology class. But I will give you the distinction of what types it is further divided into. So, we have habits, we have classical conditioning, and we also have priming. Now, if you look at the earlier lectures, I have briefly defined these habits, classical conditioning and priming, and what is the meaning of that, and also about semantic and episodic. So, quickly look into what it is. So, procedural type memories are those memories which you are not aware of that they exist, but they take place, for example, riding a bicycle, playing a piano, typing on the keyboard, and so on and so forth. So, you do it with such less intention that you are not consciously aware, but then you are doing it. And declarative memories are those where you are conscious aware, so thinking about a particular event, thinking about a particular fact in life, verifying a knowledge, verifying a rule, or several other kind of memories where you are aware of it is what is declarative. Within the semantic episodic distinction, semantic memories are those memories which are based on facts, rules, knowledge, arithmetic properties, things about objects, facts about objects which you can verify, color, shape, that kind of a thing is semantic memory. So, when I say I know what an apple is, or questions like who was Christopher Columbus, or questions like who is Donald Trump, where is US, where is Europe, or facts like 2 plus 2 equals to 4, what is the meaning of addition sign, what is the meaning of a division sign, what is an integral, what is an indefinite integral, and that kind of facts which are either arithmetic rules. Facts in life or facts in knowledge are all semantic in knowledge or semantic in type. Declarative memories are those memories which we basically go ahead and remember about events. So, your first day of school, your first graduation, the graduation night, the prom night that you had after graduation, your first farewell of school, second farewell obviously you would have been to 10th and 12th class both, so 2 farewells to think about. First day in college, first day in school, any party in your life, all those kinds of events where you are personally aware of or where you are personally part of is basically what your episodic memory would consist of. Now, in the procedural type you have habits. So, habits are those facts which basically are something which happens automatically. So, habits like habits of scratching yourself, habit of touching your hair at each point of time, habits of twitching your nose. There are several habits that people have, and these are automatic kind of things, automatic kind of acts that people do, but they are not aware of. Similarly, in classical conditioning, what happens is that doing something, not knowing that you are doing that particular act or behavior for a particular reward is something called classical conditioning. So, buying something because something else is free with it, or thinking positively about someone because something has been offered to you, for thinking positively about that person is classical conditioning. In priming, brief kind of information or a brief information is presented to you, and this information leads you to basically go ahead and access memory or verify a particular fact. So, before knowing someone, if some kind of information is provided to you very distinctly or very implicitly about this person, your first impression of the person would be changed according to it, and so that is what is priming. So, in this particular lecture we will be mainly focusing on semantic memory. So, what we look into is what is semantic memory, what are the basic steps of formation of semantic memory, what are the various tools which are used for accessing it, the models which explain it, the various underlying limitations of the various model, and what does it explain, what does it do for us, and so on and so forth. So, that is what we will be looking in this first lecture. So, let us continue with our idea of semantic memory. In the next coming lecture, we will also look on a part of episodic memory or visual memory. So, then what is obvious to us is that people have a lot of knowledge, they hold on to a lot of knowledge around this world or about this world with them at each point of time. So, from the time when you are born to the present time, you have a lot of information with you about the world around you, about the environment around you, about people around you, and so they are stored in your personal memory. And most of this information which is stored may be personal and may not be personal in nature. For example, something which does not concern you, facts like where is America does not concern you, and so it is stored, and there will be other facts like something about when is your birth date or what is the color that you like are also stored onto it. So, a lot of memory is stored, a lot of information is stored in your memory. Now, this contains, as I said, knowledge relating to definitions of words, arithmetic facts, procedures, historical and scientific geographic knowledge, and so on and so forth. And so, most of these are semantic in nature. So, any memory which is not concerning you or concerning yourself into it or does not form around you is semantic knowledge. So, facts that can be tested, facts that can be verified, facts that you learn from people around you, and facts that are helpful for you in terms of making you live this world are basically semantic in nature. Now, basically then how is memory arranged? What is the way in memory arranged? And one of the earliest metaphor or one of the earliest analog of how memory is arranged is basically the bookshelf metaphor. So it's, and this is the semantic memory that I am talking about. So knowledge, facts, ideas, arithmetic properties, and all those, how are they arranged? One of the basic metaphor, or one of the primary metaphor is the bookshelf. So basically it's believed that just like when you go to a library, how do you search a book? So the best way, if you have been to a library, nowadays there are computer programs like Ellipsis which actually help you into finding a book. But if you go to an old library where they don't have this softwares for helping you to find out how to locate a book, you would find out that there are still the old methods of finding a book. And how does that work? So you basically go to a particular desk which is called the naming catalog. So it could be either a naming catalog and or a place catalog. So a naming catalog would have names of authors, and a place catalog or a title catalog will have titles of authors. So you choose one of this catalog, and so let's say I choose the title catalog or the subject catalog. So I choose that let's say I choose the naming catalog. Now suppose I am looking for a particular book. I am looking for the book Alice in Wonderland. And so if I am looking for Alice in Wonderland, I will have to search from something called the A. So I look for A of all the books which are available in A, and within A there will be several variations from AA to AZ. And so within AAA you will have several books, AB you will have several books, AC you will have several books. And so when you go through that, Alice in Wonderland is AL. So I will go to AL and then I will search for the particular book. So within AL you will have lots of books. So I will come to the basic book. Within that particular book also, Alice in Wonderland, there will be several versions of it, the abridged version, the main version, the total version. And so I will look at that, and then there will be something called a calling number, or basically an accession number, and I will look at the accession number. Then I will go to the row, the main library where books are arranged, start, and then I also search for, I will look for the particular accession number, because books are arranged according to accession numbers, and I will look for that particular 3-digit, 4-digit accession number, and I will find that version of the book. So this is basically how the bookshelf metaphor really works. It is believed that semantic memory also follows a metaphor like this. This is how most items or most facts are arranged in semantic memory. So information in memory, they consist of knowledge of specific events and memory for general knowledge. As I said, basically most information in memory will be either personal or will be either general knowledge. Think it is of how general knowledge is facts about general knowledge are stored, and so mostly they follow a metaphor which is equal to a bookshelf. Now the fact here is that the question that do we have this kind of a distinction in declarative memory. Now in the last class we saw that the debate over the existence of procedural and declarative memory. In this particular lecture we will see a debate, or we will discuss a debate on the existence of semantic and episodic memory. So whether there are two kinds of memory, and if there are, then what is the way in which they are arranged and what are their properties. So N. Kelvin in 1972-1983 he argued that LTM contains of two stores, basically the episodic and the semantic store, which are very highly distinct. They are distinct stores, because one store stores facts, knowledge, and that kind of a thing. So you don't need you to think about it, think about anything, or think about any personal relevance information there. And the other store is the declarative store, where the episodic store, where you have information which is personal in content. And so you argue that these are the two kind of store. An interesting fact here, the fact is that the episodic store cannot exist without the semantic store. So some kind of information is always borrowed from the semantic store. And when we end this section, we will also talk about something called scripts and schemas. And schemas and scripts are the way of how the semantic store interferes or basically aids the episodic store. Now the episodic store, think of the episodic store when I am thinking about a particular party or a particular your graduation night, thinking about your graduation night, if that is what I am thinking about, it has a lot of information onto it. But each information follows a certain rule or follows a certain structure, and this structure is, so when you think about a party, you think about a routine of what happens in a party, and that is what basically scripts are. Scripts are schema for, it's basically a schema for routines. We will come to that. So basically there are certain steps through a party, and that is what you tend to remember. In that particular way you tend to remember. So although the facts may vary from person to person, but a graduation night, what happens in a graduation night would be similar to most people, and that is what a script is all about. And the idea that this is what happens in a graduation night: you go there, you do something, you do a little bit of dancing, lot of chatting, Mr. and Mrs. Miss graduation is named, then you drink the punch or whatever you do, have a lot of fun, and maybe dance with your lady, and then you come back, and this is the kind of schema which is there, or this is the kind of structure of a graduation party which is there. And so this is what is going to happen, and this is what happens in a particular schema, in a particular event, and in particularly in the episodic store. This is how the schema really works. So as I was telling you that within the episodic memory of your graduation, of what to do and what not to do, there will be several schemas, and these schemas are part of the semantic memory. So whatever you do in your graduation party is basically an extension of the semantic memory. So episodic memories have to have semantic knowledge or semantic facts embedded into it, but not the reverse case. So semantic memories may not have things from the episodic store. So basically when I am talking to you, when I am asking you what an apple is, you need not remember the first time you learned the word apple, or the first time you were shown an apple and told what an apple is. But then with semantic memory, this is the independence that you have, but with episodic memory, this is not the independence that you have. When you describe an apple, you have to know what an apple is, or what defines an apple. For example, a certain shape, certain color, that kind of a thing has to be there. But you can also define or tell me the first time you heard the word apple, and that is basically episodic knowledge. So let's look at the distinction of the episodic and semantic memory. And so quick distinctions: episodic memory, as it said, it enables people to travel back in time and become consciously aware of witnessing or participating in events in earlier life. So basically what episodic memory does is that it gives you this confidence, it gives you that freedom to travel back in time. So here I can travel in time, and so time travel has not been invented, but with memory studies you do travel back in time to that particular event. It becomes live onto you. So episodic memory gives you this particular freedom to travel back in time, and you can also witness that particular event. So although you cannot do anything to the event, you can only remember it as a third person perspective. So you can see an event unfold in front of you, you see yourself unfolding in front of you, but you cannot participate into it, and that's the main problem with episodic memory. So you can view, you can consciously feel the event, but not change it in any way, and that is why this time travel has a limitation. So you can travel back, but cannot do anything, cannot disturb anything into it. And so that is what is episodic memory. When the semantic memory, you have it contains general and world knowledge. So basically all knowledge is about where Africa is, where America is, what is Germany, where is Germany, who was Hitler, who was Napoleon, who is the Pope, who is the current Prime Minister of a particular country, who is Barack Obama, and all kind of informations are stored here. So it's basically general world knowledge. Arithmetic rules like 2 plus 2, 4 plus 4, 2 into 2, and all those kinds of high arithmetic rules. Past tense of verbs, like what is the past tense of do, what is the present tense of any verb. So run makes ran, running, that kind of a thing. So these kind of information which is there, which basically is world knowledge, or basically is knowledge, is what is semantic memory. So a quick distinction of these. So episodic memory has to deal with personal experiences. So it is everything which is personal to you, which you are involved into, which yourself is the concern, is what is episodic memory, whereas semantic memory deals with facts and concepts. So it deals with those information which is world knowledge. So you may be part of it, you may not be part of it, but then this is a fact, this is something which everybody shares, and that is what semantic memory is. Now when I say remember when, it is basically episodic memory. So I am talking about the time, and that leads to the third definition or the third quality of episodic memory, but we will come to that in a minute. So when I am saying remember when, so remember when an incident happened, I am actually asking you to access an episodic memory. But I ask you questions like remember what is a table, what is a chair, things like what is an apple, what is water, and all those kind of information. So remember what is generally a concept of semantic memory. Now episodic memories are temporally organized, and so it is time analysis or time based analysis. So you can see an event unfold in real time when you are accessing an episodic memory. So it's just like the timeline concept in your Facebook. So there are certain events put onto the timeline concept, and as you visit it, you can see the event fold in real time. That is what is the episodic memory. But then when you have semantic memory, it is related or it is arranged in terms of meaning. So meaning related arrangement is semantic memory, and so this is a classic definition or distinction between the episodic and semantic memory. And so there are several evidences which were there to basically prove that these kind of memory systems exist, and one of the famous cases or one of the famous evidences was provided by Sacheter in 1996, and so he studied a particular brain damaged person, a brain damaged patient called Jean, and when he studied this brain damaged person, what he found out that a certain region of the brain specifically inhabited episodic memory, but it did not inhabit the semantic memory. So this person was able to access semantic memory, tell about facts about the world knowledge, but personal events this person could not remember back. Another evidence which is provided for this distinction of episodic semantic memory was by Tulving in 1989, where he looked at cerebral blood flow, and he looked at cerebral blood flow when a person was accessing semantic memory and when he was accessing an episodic memory, and he found out this cerebral blood flow that was measured through a PET scan, they were different. So basically different kind of blood flows exist in different regions of the brain, and so that is what the third thing is. Different brain regions are involved with the semantic and episodic memories. So the blood flow was different, not only the flow, the regions of the brain were also different for semantic and episodic memory. So now we come to know that the semantic memory is a huge store. It has a lot of information arranged onto it, right? A huge capacity. Now if a memory system has a huge capacity, because the world knowledge that you have is huge, you learn everything every day you learn something or the other, a huge amount of knowledge which is there. So how are they organized? What is the way in which this is organized? And so several debates were coming up. There were several propositions of how they were organized. So on the basis of that, the whole idea of semantic models of semantic knowledge were proposed. Now one of the primary things that were happening is that researchers working in the field of artificial intelligence and computer science, who were modeling memory back in the 80s and 90s, those people, they wanted to build a common sense knowledge system, a system which has common sense, which can explain common sense things like how to do something, how to open a lid of jar. So how does a system like this operate? Because common sense exists from world knowledge only, and so they were thinking of designing a model. Now what they said is that with a lot of knowledge that we have, the kind of knowledge that we have a lot of implicit knowledge hidden within the kind of knowledge that we have, which we are not aware of. Now take the example of a shampoo bottle. Now if you look at a shampoo bottle and if you look at the directions that it says wet hair, take a little bit, apply, rinse, wash and repeat. So if a robot is given this to do, if a computer is given to do this, what it will do is it will keep on doing this cycle of wetting the hair, taking a little bit shampoo, putting it on, rinsing it, washing it and repeating it till the bottle is finished. But then with most of us, that is not what we do. We tend to stop after 1 or 2 rinses and we don't go on continuing. So, where does the knowledge, the implicit knowledge of stopping after 1 or 2 rinses is, where does it come from or how it is arranged? And so, that particular store or that particular idea of arrangement was what was people looking at. How is this idea or this implicit knowledge, where is it stored with the world knowledge, because world knowledge says that you repeat. So, how many times you repeat, that is the other question. So, implicit knowledge in everyday routine inform you to know a lot of things and a lot of other things which you do not know that you know, but you take it for granted. So, knowledge of language has an associated great deal of implicit knowledge. Also, things like common things like this, certain other implicit knowledge. For example, when I say the dragon had a liver. Now, when I say a dragon had liver, you do not have to go to check the whole idea of what a dragon is or the whole structure of a dragon, go to a museum and find out whether it has or not. You know, the dragons were kind of mammals and most mammals tends to have liver, and so it can be generalized. So, this is implicit knowledge that if men here have or birds like dragon had liver, so the dragon also had liver, and so this is implicit knowledge. And so, people wanted to test how is this implicit knowledge actually arranged. So, one of the other reasons for making the inferences or thinking about or modeling presenting models of implicit knowledge or semantic memory was how was the mental representations of various knowledge arranged. So, people also wanted to know when a fact or a knowledge is stored in a memory system, what is the way in which these representations are stored. Another interesting thing that was happening is that how are they accessed, what is the speed of accessing. So, basically questions like this were asked, that name words which has first letter L and name quickly words which has the fourth letter L. For example, the first word could be livid and so words with first letter L and the third letter is L, calculus, and so or the seventh letter word L. Now, if I ask you to name the number of words which are with first letter L and the number of words which are third letter or fourth letter L, you will end up telling me more words which have first letter L and then the number of words which have the seventh or third or fourth or fifth letter L. Why? Because this shows the speed with which of how many words you can retrieve can actually tell you how is the mental dictionary organized. So, basically mental dictionary is then organized with the first letter. Remember the metaphor that we used in the bookshelf. So, basically the first letter of Alice in Wonderland, that AL is how it is arranged. So, A is Alice and so you will find a lot of it, and so Alice in Wonderland is arranged with AL, the first 2 letters, and this is how this thing really works. So, basically then several models were proposed of the semantic memory, and we will look into a few models of semantic memory which are here. We will look into a couple of models. We will also look at how these models compare with each other and how one appreciates one model, goes ahead and cancels or basically adds on to the limitation of the other model, and how is semantic memory arranged. So, basically it was the hierarchical semantic model was the first model, and so this model does a number of things. It tries to tell us how limited database is arranged for the huge knowledge. So, how is the database for a huge knowledge that we have is arranged, and or basically the number of knowledge that we have, the number of facts and knowledge and things, semantic things that we have, how they are arranged. Also, any model of semantic memory should be made in such a way that it should not store redundant things, right. Things like let us say a dog has 4 legs, right, and cat has 4 leg, and let's say any other animal has 4 leg. So when I say that, so each time when I present a dog has 4 leg, cat has 4 leg, animal has 4 leg, so basically it should not be repeated. This 4 leg, the idea that this particular kind of concept, this particular kind of object has 4 legs should not be repeated with each instance, which means that the idea that most mammals, because anything which falls under mammal should have a 4 leg, it should be arranged in such a way that the higher category, or the idea that any particular item within a category should have 4 leg, and this 4 leg should be at the top of the feature, at the top level. So if I am thinking of a hierarchical semantic model, which means that knowledge is arranged in terms of hierarchy, any knowledge is arranged in terms of hierarchy, the top level hierarchy should have these facts, because anything under that hierarchy should have 4 legs. So lion, tiger and all kind of mammals I am talking about all follow under the animal category or the mammal category, and so the model should be made in such a way that the mammal category should have inbuilt the idea that it has 4 legs. So basically that kind of thing is there, and what it does is it preserves something called cognitive economy, which where the properties and facts are stored in the highest level possible. So basically if a particular category, if a particular structure is designed in such a way that properties and facts of the category, anything which falls in the category and the main facts of those categories should be at the highest level, and then within that you will have lower levels onto it. And so the first model of semantic memory was proposed by someone called Collins and Quillin, and they tested the idea that semantic memory is analogous to a network of connected ideas. So what Collins and Quillin they said is that basically semantic memory is something. So semantic memory is basically an arrangement of network of connected ideas. So they define that any word or concept is arranged in terms of nodes and pointers towards nodes. So these are two nodes, this is one node, node 1, and this is node 2. So then two concepts, two words are related to each other through a node, and the junction or the connection between two nodes is provided by a pointer. So people who are familiar with programming or C programming, C++ programming, they are familiar with this idea. Now this, in terms of programming, this is a memory allocation space which the computer provides you, and the pointer points how two memory allocation spaces are basically connected. In terms of the hierarchical model by Quillin and Quillin, what it says is that this is the memory area, memory allocation, or this is the node for a particular word, and this is the node for a particular word. And so if two words are there, then they have different memory allocation or different structures or different places allocated in semantic memory, and they are connected by a pointer which points from the highest node to the lowest node. So basically then what they said is the model consists of nodes. In this case, words are concepts, and each node is connected to a related node by means of a pointers, and that is what I was also telling you. So if this is the node, let's say this is the node for any kind of dog. So maybe a German Shepherd. This is the node for a dog. And so what happens is these two nodes are connected, because within dog you will have German Shepherd, and within the German Shepherd also you can have another node which is different kind of German Shepherds which would be there. And so what happens is within dog the German Shepherd will fall, and within the German Shepherd there will be other nodes. Also within the dog category there will be other nodes which are there. So I will have a Pomeranian node also, and so on and so forth. So what is the fact here? This is how information is stored, and the dog will be again following under the mammal node, the node for mammal, and so on and so forth. So, we will come to that in a minute. So, basically that is what their idea is, that this is how the arrangement is, nodes and then connection of nodes. Now, thus a node that corresponds to a given word or concept together with the pointers to other nodes to which the first node is connected constitutes a semantic memory. So, basically semantic memory is this kind of a structure, and this kind of a structure that I am was talking about, of a higher node to a lower node kind of a thing, is called the semantic memory network. So, semantic network is the network of mammal, then following to dog, and then following to a German shepherd. This is a network, but dog and German shepherd within each other is what is a node to node connection, and the pointers are the pointing or what leads to what kind of a thing. So, that is what this says, and so the collection of nodes associated with all the words and concepts are called the semantic network. So, let us look into this particular thing. So, quickly look into this. As you can see here, I will first rub this thing here, quickly rub whatever is written here to show you what is there. And so, this is a classic network that I was talking about, and so as you can see here, what you see here is a very small network, and so as you see, this is the network of vehicle under which a car falls, under which a truck falls, and as you can see, the vehicle has several properties which most vehicles which follow under the vehicle node would have, and these properties are: it moves around, it needs fuel, it is man made. So, car is also a vehicle, so it has, by default, it has moves around, needs fuel, and man made. These are the properties of the node. Remember the cognitive economy that we talked about, and so by putting these three features at the top node, which is, this is called the supraordinate node, and this is called the subordinate node. Supraordinate node is the node higher than a particular node of concern, and sub node is a node which follows under the supraordinate node. So, these properties then by default should be a property of any member of the vehicle, and so when I talk about, and this is the link that is there, and this is the node. So, this is the pointer that I was talking about, and so within vehicle will have these three features are the feature of any vehicle, and so these features should also be in car. When I talk about car also moves around, car also needs fuel, car also is man made, and when I talk about car, it has four wheels, has an engine and a window, and so within the car node, but then all vehicles may not have four wheels, because two wheeler is also a vehicle, so it may not have four wheels, but it moves around. So, these features are common. So, these features are common features to any item which is here, but features which are here may not be here. And so, four wheels, engine and window, and within the car then they have two more nodes. One is the truck node, car follows a truck, and then I have a variety of car, which is the sports car. It runs very fast, it is irresistible. So, I will have a sports car, a sedan, and so on and so forth, which follow under the car node. Also, you will find out that this is a sub node, and this is the supraordinate node. So, any feature of the car will always be here. So, it always, a sports car will have four wheels, will also have windows and engines, but then every car will not run fast, and so this kind of a reverse pointer or this kind of a reverse matching is not true, but forward matching is always true. Also, truck is kind of a car which has four wheels, but it special toll on German highways and transport loads are something which this node does not have. So, they are separate with each other, but then a truck will always have four wheels, it will have an engine, it will have windows onto it, but two more features of it which may not be consistent with the car, and all of them will have these four features. So, basically this is how it is the arrangement of the Quillin and Collins model of semantic memory. He says there is a network of nodes, and these network of nodes are connected by pointers, and so one network leads to the other. Also, facts which are stored at the highest network, which is the superordinate node. So, the highest node is called the superordinate node, and the one which is beside it is called the subordinate node. The subordinate node. So, features which are at the superordinate node will always be shared by features of the subordinate node. Feature superordinate is shared by features of the subordinate, but then features of the subordinate may or may not be shared by the superordinate node. So, this is how Quillin and Quillin define the idea of semantic memory. So, they tested the principle of cognitive economy in their model, and as I said, one of the things that needs to be tested with most models of semantic memory is the idea of cognitive economy, that properties which have the highest place in a model, it should have the basic concepts or all properties of the concept. So, words and concepts should be always at the highest node or the superordinate node. So, they tested the principle of cognitive economy with this model, and they reasoned that closer a fact is stored to a particular node, the less time it should take to verify a particular property. So, if a particular item, a particular fact or a concept is stored very close to another node, very close to another concept, it should take less time to verify than if it is stored far away, and they tested this particular thing. So, they reported that people took less time to respond to sentences whose representation should span 2 levels. A canary is a bird, than to representation which should span 3 levels. So, then let us look at this particular how this arrangement is. So, basically I have the arrangement of animal, and within animal we have mammals and birds, and within birds I have the canary, the parrot, and so on and so forth. So, when I am verifying, and they said that since if cognitive economy is to be preserved, if words which are concepts, word higher order concepts should be stored above a lower order concept, if that is what the idea of cognitive economy is, because all properties of word has to be shared by canary and all property of animal has to be shared by word. If that is how the arrangement is, then people should take less time in verifying canary is a bird than verifying canary is an animal, and that is what it actually happened with them. So, they took that people they saw that people took less time to respond to sentences representation should span 2 levels, canary is a bird, than for presentation which was spanning 3 levels. So, this is 1 and 2 level, and this is 3 level. So, basically cognitive economy is preserved here. Also, the model was called the hierarchical semantic network model of semantic memory. So, this particular thing, because what I have is the higher order concepts or the concepts which have basic features which every item on that particular concept or every item within that concept should be at the highest level, and within that we will have other items. And so, the properties of concept will be shared by any item which is under that particular concept. Now, the nodes in the model are organized in hierarchy. As I said, there is a top node, then there is a another node, and then there is another node, and node, and all are connected by pointers. Now, a very good example of thinking of it is, think of your windows. When you think about your windows, you have this tree structure, and so there are folders within folders within folders within folders. If you have ever worked with the Linux system, you will find out that there is a path that we talk about, PATH, and this path is basically how nodes are connected. So, because if you have to, so let us say there is in Linux you have the first part as /root, and then within that you have /etc, and then you have something, and then within this you have generally have stc, and within stc you have usr, which is the user, and then you have the home, and then you have your desktop. So, if you want to reach your desktop, you have to go through this path, and this is how the semantic network is also connected. So, root is the one which is the highest level concept with the superordinate concept, within that the etc is there, which is the subordinate concept, within that the stc is there, which is another store which is there, within that user is there, within that home is there, and with that your area is there, and which is basically your desktop. Similarly, they have a system like this. So, then most nodes have superordinate nodes and subordinate nodes. So, nodes above a particular node is superordinate, just as we saw in this particular thing. In this particular example, so what we had is vehicle is a superordinate node and truck is a subordinate node, or sports car is a subordinate node. So, this is what it has been saying here. Now, with a model like this, where we have this kind of superordinate subordinate node and things which are saved in this way, a good experiment was done by Mayer and Skinwelt in 71, and they reasoned beautifully they gave this reason that if related words are stored close on one network and they are connected to one another in a semantic network, then when one node is energized, energy should actually spread to related nodes. One reason is that spreading activation, the idea that exciting a particular network along a connection of network in the semantic network. So, let us try to understand what this is. So, we have the animal node, and within the animal node we will have something called the birds and mammals, and within the birds and mammals we will have let us say a parrot, and another one is let us say a robin, and within the mammal we have a tiger and we have a lion. So, what he says is that when since birds and mammals are not connected to each other, but then what he says is that when somebody is accessing the animal node, this activation that follows to the bird should basically go ahead and excite both parrot and robin at the same time, or with so robin may not be connected to tiger in any way, but then if they are connected in some way, if these nodes, because some kind of connection would be there between robin and tiger, of course very difficult to explain what it is, but they might both be coming from animals, and so some kind of connection would be spread between them. So, when I energize this animal, or when somebody starts traveling from this animal down to birds, both this node will be activated, right. And so, within the birds you will have colorful words, non-colorful words, and within the colorful and non-colorful you will have the talkative words, non-talkative words, and so on and so forth. So, what they said is that when an excitation moves down a node like this, what would happen is this excitation will not only spread to one node, but it will also spread to excitation spreads along connection of nodes in a semantic network. So, this excitation would also go ahead and connect to tiger. So, tiger will be weakly excited, but then it will not be excited. Now, how robin is connected to tiger is very difficult to look at, but then there will be certain mammal which may be related to robin in some way or parrot in some way, and so that excitation will always be there or connected there. And that is why they said this, is because we have always found out that when I say queen, people say king. When I say bread, people say butter. Now, when you look into it, bread and butter, they are two different things. King and queen are two different concepts which are altogether. Queen is from the female category, king is from the male category, but queen and queen are related to each other, and this relation is basically can only be explained through the idea of this spreading activation. What happens is when a node is energized, this energy also spreads. Now, it does not only go to the node which is subserved with it. So, we will have reptiles also, for example. So, when animal is excited, reptile nodes also get excited onto it. So, king, queen, although being this is female and male, and so on top of it, if we look into the node of animals. So, within animals we have male and female, within king and queen. So, although they are different, but some kind of activity relate them, and so this was an basic example to show that these nodes are connected to each other. Now, there are several limitations to this particular the hierarchical model of semantic memory. One is about cognitive economy, and so Conrad in 1972 they found that people are no faster to verify sentences like a shark can move than a fish can move or an animal can move. So, what they found out is that even if we span, so if we span let us say 2 levels, or if we span 4 levels on a network, so let us say it is a 4 level network, 4 nodes. So, when we verify a sentence which is 4 node far from the superordinate node, people take almost the same time, and so this idea of cognitive economy was not preserved by this hierarchical semantical network. Another problem was the structure of the hierarchy itself. So, Rips and Shobin-Smith, they showed that participants were faster to verify a pig is a mammal than to verify a pig is an animal. Basically, they quickly identified pig is an animal, then pig is a mammal. Now, if you look into it, animal is the highest node, and then within that you have mammal, and within that you have several other things, let us say 2 more nodes are there, and then you have the pig, which is actually a mammal. So, when people verify pig is an animal, which is, let us say, that is directly connected here. So, we have 1 node and 2 nodes. So, when people are verifying 1, 2 and 3, when people are verifying 2 levels and people are verifying 3 levels. So, people verify 3 levels faster than 2 levels, and so, and this is what the thing would look like. So, they found out that this idea of hierarchical structure was violated by the hierarchical network model. Also, typicality effect was another reason or another limitation of the hierarchical semantic model. What it says is that birds which were typical, for example, robin, parrot, birds of sparrow, these were faster in verification. So, when people verified a robin is a bird or a parrot is a bird, they were faster to say yes, verifying the sentence, than to verify sentences like ostrich is a bird or a turkey is a bird or a hen is a bird. Now, if you look into it, both hen, turkey and ostrich are all birds, but then people took more time to verify these sentences. Now, although if you look into it, ostriches and turkeys both have the same kind of structure, the same kind of features as a robin or a parrot would have, but when we are verifying this, when people verify this kind of a structure and people verify this kind of a typical versus non-typical instance of a particular concept, people are more prone to verifying the more typical instance than not typical. So, the idea that all elements of a concept are not arranged or not verified in the same manner, and so this is typical defect, and so Rips found that problem with hierarchical semantic model. So, since these were the problem that were there, the violations which were there, another model called the feature comparison model was actually proposed, which would go ahead and solve some of the problems which the model of hierarchical semantic network was actually doing. So, what was the model like? So, Smith, Sobhan and Rips, they proposed an alternative model to the hierarchical semantic model, which was called the feature comparison model of semantic memory. The assumption was the meaning of any word or concept, it consists of set of features or elements called features, and features come in 2 types. So, he said, what they said is that semantic memory is not arranged in terms of some kind of a structure or some kind of hierarchical structure, but they are arranged in a way in which there are certain features. So, there are 2 basic features that we talk about. So, when I am looking at any concept, for example, I am looking at dog. So, the dog has 2 kinds of features. One is called the defining features of a dog, and then there is a characteristic features. So, facts like it barks, it has 4 legs, it has a tail which wags are defining features of a dog, because most dogs will have them, and then there are characteristic features which some dogs may have and some dogs may not have. For example, there is a dog that's out there which does not bark, and then there is a dog which has very less tail. For example, you have a dog which has no tail at all, and then you have a dog which has a huge tail, or there is a dog which or think of a dog which has 3 legs only. So, how do we accommodate for that? So, that kind of a thing is there, and so most dogs, whatever they have is the defining feature, and some dogs may have features which are extra, which are called characteristic features, and so this is what it is. So, the meaning of a word or concept consists of set of elements called features, and features generally come of 2 types. Defining features, features must be present in every example. So, every dog should have them, 4 legs, barking, or tail, or greedy, or man's best friend is what most dogs should have, and so these are defining features. And characteristic features are those features which are usually not necessarily, which are usually but not necessarily present. For example, barking, as I said, or other features, for example, big tail, or facts like drooping ears, long teeth, these kind of features may be there, may not be there, or a glossy skin may not be there, or the height. For example, Saint Bernards are dogs which are very high, and Chihuahua is a dog which looks like a cat, and so they may not have the same feature. So, for them, this is the kind of network they thought about, this is the kind of feature related fact that they thought about, and so If you look at attribute or feature of a model, for example, if I am looking at a robin and if I am looking at a bird, so there are two level concepts. Bird will follow, or birds are the superordinate node and the robin is the subordinate node. So, if you look into it, both are physical object, both are living, both are animate, both are feathered. So, these are the features which are defining. So, any bird has physical organism, is living, is animate and is feathered, but then this particular thing is called the characteristic feature of a robin, because most bird may not be red feathered and or red breasted, and so this is the characteristic feature, and all these are the defining features, because defining features is something which most of the elements of this concept should have. Whereas, if you look into the comparison with hierarchical model says animal is a bird which has feathers, is a robin which has red breasted, and so this kind of thing, this network has a problem, because they should share. So, if a bird has feathers and robin should have feathers, but red breasted, that is the kind of problem which is there, and so this model has this problem which is solved by my feature model or the new feature model of semantic memory. So, what it says is that why does the verifying sentence problem really occurs, or how do sentence verification happens according to the feature network model or the feature model. According to the feature model, the first step is the presentation of an item. So, when I show you a new item, a test presentation is there and we retrieve features as a list of 2 nodes, and so basically C1 is the defining feature here and C0 is the characteristic feature of a particular thing. So, I present a Saint Bernard to you and I ask you to verify this, whether this is a mammal or not, whether Saint Bernard is a mammal or not. And so, when you look into it in stage 1, you look at the characteristic feature and the defining feature of Saint Bernard. So, what happens is, initially the first step is to look at all the features or gather all the features, then compare x to the criteria C0 and C1. If x is less than C0, which is the characteristic feature, which is the the defining feature. If it does not have the defining feature, for example, it barks, and so Saint Bernard does not bark, let us say, then I can move this way. So, C0 is the defining feature, C1 is the characteristic feature, and so if C0 x is less than C0 or C0 is greater than x, then I move here, execute a negative response and say it is false. So, if I have a cow, a calf, and I am trying to say to you that this is Saint Bernard, and the calf goes meow meow and does not say bow bow, which is what a dog should say, this is the defining feature of barking, and so I can execute a negative response saying this is false. Otherwise, there could be other things, that if I can also compare the characteristic feature, or if the match is not even of a characteristic feature, I can, or even if some characteristic feature matches. So, they may not be defining, but a characteristic feature. For example, I said there is a dog which does not bark, but it looks like a dog, it has a glassy screen, it has a tail which wags, and it looks more or less like a dog, droopy hairs, all those characteristic features are there, and so if it matches, even if the characteristic features matches, I can execute a positive response and say it is true. But in cases where my response, the response that I get by comparing the characteristic and defining features is in between the characteristic and defining features. So, if the amount of defining features is very high, I say yes, my new item is a part of this particular list, but then if it is very low, I say it is not part of a list. So, if it does not have a defining feature, I say false. If it has very high amount of defining features or some very high characteristic feature, I say it is yes. But if it is in a mediocre range, if it is having neither very high characteristic feature nor very less than defining feature, I go ahead and do that. I compare the defining features then. So, defining features does not come into play in comparison in the feature model until and unless it falls, the comparison of features falls in the mediocre range when the characteristic feature is looked at. So, first step is I gather all the features, then I look at the characteristic feature of a particular item which is being presented. If the characterized feature is very less, is matching the characteristic feature that the new item has matching to the concept is very low, I will say no, it is not part of this particular category. If it is very high, I say it is a part of it. In circumstances when the characteristic feature is somewhat mediocre, it lies between the defining and the characteristic features, or not too much of characteristic features is present, but it has some characteristic features, I go ahead and compare the defining features only, the defining features only. If there is a match with the defining feature, I execute a true response or I execute a false response, and this is the two stage characteristic feature comparison for semantic categories. So, again very quickly what I do is, if a new instance comes in, first I compare the characteristic feature, high comparison of characteristic feature or high number of characteristic features present, I say this incident belong, or this incident or this item belongs to my category. Low amount of characteristic feature present, I say it does not belong. If the amount of characteristic feature present is somewhat in between low and high, I go ahead and look at the defining features. If the defining features is high, I say a match is there, defining features is low, I say execute a negative response and it is false. So, feature comparison model, why it is good? Because it can explain some of the shortcomings of the earlier model. First, typicality effect. Sentences like a robin is a bird are verified more quickly than a turkey is a bird, because robin becomes more typical example of birds than thought to share more characteristic features with the bird. So, robin stares, although it has a number of defining features, but when you actually look at robin, it has a lot of characteristic features, add on features with the bird, and so they are verified much quicker. But when I look at a turkey, when I look at an ostrich, they do not have a number of characteristic features. So, a stage 2 verification has to be looked at. But what happens is, the comparison with robin is only a stage 1, it has a lot of characteristic features which is of the bird, and so it is categorized, and it is easy to verify robin is a bird. Also, category size effect, what it says is the category goes higher. So, if there is a subordinate superordinate category, and within that there is a subordinate category, if the category is small, then the characteristic feature list of characteristic features will be small, and so verification will take less time. But if a category is huge, if I am talking about mammals, then there will be all kind of mammals which is there, and so if I am talking about a system like that, what will happen is the verification time will be more. And so, as categories grow, as the number of categories grow, as the kind of verification category is huge, it will take more and more time. This is called the category size effect. Now, what is the criticism to that? The criticism to this theory is that there is no existence of defining features. What is a defining feature? Nobody knows, and so there is no no existence for what a defining feature should be. Suppose a bird has clipped wings, will it be called a bird? So, what could be called a defining feature is not very forthcoming here, or not very present here. So, in this lecture we looked at what is semantic memory, we looked at how they are arranged, we looked at the episodic semantic distinction, and we also looked at the two basic models, the hierarchical semantic model and the feature comparison model, and how these models compare to each other, and they go ahead and sort of complement each other. In the next lecture we will look at some other models of semantic memory, and also something of how semantic memory really works. Thank you.